Hi, I'm going to provide a brief introduction to machine learning in this video, and we're going to take a very simple look at machine learning. This is like peeling back the layers of an onion. So we're not going to get into the deep math that's associated with machine learning. We're going to keep it at a higher level so that you can understand really how to apply machine learning, and also so that you can have conversations about it without feeling like it's magic. So it's actually not that complicated. I'm going to start off by explaining a little bit how computers traditionally have been programmed, as well as how humans go about learning. So the way computers traditionally have been coded is to use rules. And rules use very basic approach where we give a set of steps to the computer and it executes them. And so, for example, if A is greater than 1, then do X. So that's a very simple step, right? And you could build these steps up to get really a complex set of steps, and that's how software is traditionally created. Now, humans actually can learn in this way as well. If I wanted to learn how to play a game, maybe a game of cards, I would do the same thing where someone would give me a set of rules and I would follow them, and that's how I would learn to play, initially at least. And so if someone gave me a deck of cards and wanted me to shuffle them and deal them, they would tell me how to shuffle them, they might show me how to shuffle them, and then they would say, deal them one by one, left to right, going clockwise. And so that's a set of steps that someone could tell me, and me as a human could listen to that and learn to follow those rules and to play that game. So that's one form, really, of how we as humans learn, and it's how traditionally we have programmed computers. However, that is not how machine learning functions. So machine learning is more sophisticated in that it really works like we humans learn a lot of things, which is by example. So this is interesting because we humans, we actually learn a lot of information by example, and computers can do the same thing using machine learning algorithms. And what do I mean by this? So let me show you an example of this. So here's the letter A, and I've given you many examples of this letter. And me as a human, I could learn to recognize the letter A just by seeing a bunch of examples. How does this happen? Well, we don't really know, but our brain is able to process this and learn. How would we do this for a computer using a traditional approach? This would be very difficult. You can see how many variations of this letter there are. You might try and write an equation that would mathematically describe the line that makes up this line of A, and this line of A, and that line of A, and so on. That would be one approach you could take. However, then when you got to this, it would be a completely different equation, and so would this. And ultimately, it'd be very, very difficult to write an equation that would represent all these letters because there's so much variation in them. even myself, if I try and write this letter A the same, it's going to come out a little different. My handwriting is not very precise. And each time I write the letter A, there's a lot of similarity, but there's also variation in it. And so defining those rules is very difficult to describe as a human. And so it's not really the best approach to try and have a computer recognize the letter either. So what's the other approach? So by actually giving it a bunch of examples, we can have the machine learn just very similarly. Humans learn. We don't know if they learn the same way, but it's a similar approach. We give a lot of examples, and then the machine will learn just like humans learn. So let me draw some other letters here too. So let's draw B. And so there's some B's and some C's. And C might be a little easier. There's less variation there, but so there are some letters. And how can I now teach the computer about this? Well, I can construct these letters in a way that the machine can process them. So how would I do that? Well, how do we do it on a computer screen? A computer screen is made up of a bunch of pixels, and each pixel has an X and a Y coordinate. That's our X, here's our Y, and we don't often see these pixels because our computer screens are very high resolution these days, and you'd have to get pretty close to the screen to be able to see the pixels. And if you did, though, you would see that these letters are actually just made up of a bunch of dots. So let me just draw one of these letters. Okay, so the way this would be represented in the computer is these pixels would be filled in entirely, and it looks blocky here, but if you were to step back, it wouldn't be as blocky. But essentially now what we're saying is for a given XY coordinate, let's start here at 0, 0. And go on, so on, and so on. And then we'll say whether or not the bit is on. And then we'll also say what the letter is. So in this case, the letter is A that we're drawing, and these are all off, so we'll represent off with 0. And eventually we'll get here, so this is 0, 1, 2, 3, and this is 0, 1, 2, 3. So that's 3, 3, and that's on. And that's the letter A. Okay? So what we could do is complete filling out this table, and then we would have a representation of the letter A in a form that the computer can process it. Okay? So we could do this for these other letters here as well, and fill out the little charts, and continue doing that for a bunch of letters A, and we would have a big table, and it would contain all this information. And what we do is we call this our training data. So training data is the information that you use to train the computer when you're doing machine learning. And the idea is if we create enough training data and give it enough examples, the computer will learn the patterns associated with, in this case, the letters A, B, C, etc., and then be able to recognize the character once you give it a new character that it's never seen before. Essentially what the machine is going to do is going to create a machine learning algorithm, or it's going to use machine learning algorithms to create a new algorithm to recognize letters. So we're going to have a function, and it's going to take a matrix, we'll call it Z, and it is going to output a letter. And that matrix, it essentially looks like this, our XY coordinates, and whether the things are on and off, right? And then it's going to output the letter A. And it's also going to output a confidence level associated with that classification. So using this confidence, we can know statistically how confident the machine is in how much this was similar to the training data, where it learned that something like this looked like an A. And so really that is what it's about. It's all about statistics. So this is a statistical inference, essentially, where it looks at enough data and it's able to create an algorithm based upon all of the data that it was given using statistical techniques. And so in a nutshell, that's what machine learning is. And there's more complex forms of machine learning. You may have heard of deep learning, and that's something we'll get to in a future video. But for now, using traditional approaches in machine learning is really this simple. It's creating a bunch of examples, a bunch of training data, and providing it to the computer in a way such as this table here, that it can then create its own algorithm using statistics to then make predictions about future data that it gets, where the answer here is not provided. The machine actually has to provide the answer based on this data, where it's learned enough statistical patterns that it can do that. And of course, the important thing about training data is that it's representative of the information that you'll get. And so you don't want to give it all data that looks the same, because then it would be really good at guessing A's that look like that, but then it wouldn't be good at guessing A's that look like that. This is called overfitting, when you give it too much training data that looks the same and doesn't have enough variation. And so what we want to do is provide representative data that has enough variation that it covers really the population that represents the real world. And so that's machine learning introduction in a nutshell. We'll cover some more advanced topics in a future video. Thanks for joining.